So now we're coming back, and we've made an adjustment, which some of you understand. And so because we're stopping the continuation into chapter 10, which we had a little bit for, that information will be good, but we're not going to stress it, and we're going to go back and pick up chapter 6 again because of its importance in testing. So the assignment that you were supposed to have done was to do the review of chapter 7 and the review of chapter 9. Okay, now, because of some confusion and all, the review is important. Why? Because it tells you whether or not you're ready to take the test. All right, and so the review should be done, and then what you're going to be assigned for this week is going to be chapter 7, test questions 1 through 4, and then chapter 9, test questions 1 through 5. Okay, so this is the new part. All right, and this was what I already had. This was the last piece of information that I gave you before we took the break, and that was to do the review on functions and the review on conic sections. Okay, now. All right, let's see. So what I want to do, because we don't have information on problems, let's turn to page 406 in the book. Turn to page 406. Chapter 7 deals with polynomial factoring. And a polynomial is just a scary name for an algebra setup, right? And what you've got to understand, first of all, is what conjugates and differences of squares are. Okay, now, is there any question on those? So if I were to ask you what is a conjugate in mathematics, you could give me an answer. No, okay. All right, conjugates are two binomials. Now, what does that mean? Binomial. All right, it's a two-term. Binomials that have the same numbers but different signs. So one's positive and one's negative, so you're going to have adding and subtracting. But the first number is the same on both, and the second number is the same on both. So when you FOIL it, you're going to have the square of the first number, you're going to have the square of the last number, but the inside and the outside will be, one will be plus, one will be minus, and they zero out. And so that's going to leave you with a difference of squares, because the middle term was, in this case, was a positive and a negative of the same numbers multiplied together. Okay? And so in factoring, one of the skills that you have to recognize is that when you have a difference of squares, you can factor it into two conjugates. Okay? Now, when you get into higher mathematics, it doesn't even have to be a perfect square, because you can leave it the square root of a number. Now, we know that the square root of 49 is 7, right? And so this will turn out to be whole numbers. But let's say that instead of 64 it was 63. Then we would just have down here the square root of 63 and the square root of 63. Right? So one of the skills that you have to elevate is that if it's not a perfect square, you still have the skills to be able to form the conjugates. Okay? Now, as you also elevate this, what happens if this is plus? If this is plus, then it would be minus a negative. And what is the square root of a negative number? It has an I in it. It's imaginary, right? And so when you elevate that, you can actually have a difference of squares where this is minus a negative and you end up with an I, and that's the whole imaginary system. And there are imaginary conjugates. Now, I'm working with a pre-calculus student, and one of the things that he has to be able to recognize is that there are always imaginary conjugates. All right, now think of this. When you do the quadratic formula, it's negative b plus or minus what? The square root of b squared minus 4ac all over 2a. Well, because of the plus or minus, if the square root is a negative, you'll have an I. And because it'll be the opposite of b plus the square root I, and opposite of b minus the square root of I, they're always in conjugates. There's always one positive and one negative, but the numbers are the same. In the case of imaginary numbers, the real is in the front where the b is, and the imaginary is where the square root is. Okay? So, conjugates is important to know and not just forget because you're done with Algebra II. You're going to see that again. The difference of squares will end up being something that you'll do more of. Now, difference of cubes. This is something that you have to memorize. There's no short way to do this. When you have the difference of cubes, you're going to have the cube root of both of these numbers. Now, it's nice if these are 3 because the cube root of it is x to the first power. But what would happen if this was 6? Hello? If this was 6, the cube root would be 1/3 of it, which will leave x squared here. And now, why is that important? What did we just get done talking about? The difference of squares. And so if I put a 6 here and here, and let's take this one with a negative sign, then this will become x squared minus y squared, which you can also factor. Right? Now, what you're starting with is factoring where you do one step and stop. Right? But because you're improving and getting into more complex math, a trick problem would be to put 6's here so that this has to factor because it's a difference of squares. If these are 6's, I'm going to have a 2 here and a 2 there. Okay, so you've got to remember that it's not always one and done. Sometimes this difference of squares can also be factored. Okay, does that make sense? Okay, now, what do we do? After we take the cube root of this, when we multiply, in order to get an x to the third, x has to be multiplied by x squared. Right? So that helps me know that I got to have an x squared here, otherwise when I'm done, I won't have the x cubed. Right? Same thing with the last term. This y has to be multiplied by a y squared. Right? Now, what happens to all the inside parts? They subtract it out, just like the conjugates did with the difference of squares. Right? So that means if this is a plus, I got to have a minus in here so that they'll subtract out. That's the way I remember it. Does that make sense? If this is a minus, then in order for them to subtract out, this has to be a plus. And then it's just the two numbers, these same two numbers multiplied together. All right, now, we've done that before to demonstrate it, but that's the quick way. All right, now here's an example. You should know, what's this the cube of? Nope, it's a square of 8, but the cube of 4. Right? What about this one? 3. 3 times 3 times 3 is 27. All right, if it were 5, what would the number be? 125. You should know those 3 for sure. All right, by the way, what's 2 to the third power? You should know it. 8. So 2 to the third power is 8. 3 to the third power is 27. 4 to the third power, and 5 to the third power. Okay, I am tutoring a 7th grader from Gwinnett County. He had to memorize all of the cubes through 7 and all of the squares through 25 for his 7th grade class. So when we were talking about this stuff, he knew the answers. And so he could work on the skill because he didn't have to work on what the value was. Does that make sense? Right? And so when you get a problem like this, because this is 4 to the third, x to the third, 3 to the third, y and w to the third, then I'm going to take the cube root of both of those and end up with 4x. Now this right here, I had started these with 6 and I changed it out, so that's a problem that's not supposed to be there. Okay. All right, that makes sense?
Sir?
All right, I didn't correct that one. All right, now, completely factor the following. All right, what do you see here? All right, 8 and 18 both have a common factor. What is it? Dos. All right, and so you pull the 2 out and you get this. Are you done? Why are you not done? Because x squared minus 9 is a, come on folks, is a what? Difference of squares. So what else do I have to do to factor this completely? What is the factoring of this binomial?
X plus 3 and x minus 3.
Thank you. X plus 3, x minus 3. So completely factoring will be 2 x plus 3, x minus 3. All right? That is a normal skill, and that's the way it'd be set up to trick people to do one and stop when there's actually 2 things you had to do. Does that make sense? Okay. Now, the discriminant. Forrester, who was the author of our book, Forrester likes to use the discriminant. The discriminant is what's under the square root in the quadratic formula, b squared minus 4ac. If b squared minus 4ac is positive and perfect, then you're going to have rational numbers as answers. You're going to have fractions and not decimals. Okay? So, the discriminant, if it's not a perfect square, then you're going to have a square root. It'll be b plus or minus the square root of something all over 2a. Right? And what happens if it's negative? If the discriminant is negative, then you have an imaginary number, or you have no solution if you're in the real number system. And that's 2 different responses to the same situation. And so, which one is right? It depends on how the question is formed, right? Because you're supposed to be able to deal with a negative square root using imaginary number I, right? You should be able to say that if it's negative, I have an imaginary number, and therefore I'll have a complex number, b, or opposite of b, plus and minus the square root with some I on the end of it. But if you're in the real number system asking for solutions, if it's negative, there's no real solution. Now, what is the graph of a quadratic with no real solution? What's it look like? So we haven't done a whole lot with graphing. Okay, where's it going to be?
Like in the middle, not.
It's going to be either up or down, but it's not going to cross the x-axis. All right, and so if it's don't want to use red. I can't erase red. Let's see if this one works. All right, so if this is my coordinate plane, if I go like this, I have a negative and a positive solution, right? If I'm up here, the x squared is positive because this is opening up, but I have the square root of a negative number for the discriminant, and so I have no real solution.
Right.
Okay. So that, and again, remember that because we've gone away from what the graphs look like. When you get into testing, a lot of times the graphs are something that they can test without you having to write a whole lot. Okay? All right, now let's move down. Let's see. By the way, this is working a whole lot better. Okay, now this one right here we worked on. If you have to factor a complicated trinomial, you're going to take the prime factors of the 20 and the prime factors of the 18. The prime factors of the 20 will go in the leading part of the binomial. The prime factors of the 18 go in the following part of the binomial, and when you do the inside-outside, it has to total the middle, the b value. All right? And sometimes there is no good way. You just have to break it down and then do what's called guess and check. All right? Because it's higher level. If you were actually doing this, you would want the factors of 360. So 360 times 1, 60, 180 times 2, and then you work them down that way, and that is crazy, right? So a lot of times it's easier just to factor them and then try them. Now, all right, what does the plus here mean? The plus here means that you are going to have the same sign numbers so that when you get the inside-outside, they're both the same sign.
Right.
Right? This says they're both positive.
Yeah.
Right? If this were a minus,
Will it be positive?
it means that they are different signs, and this tells you the sign of the larger group. Now, I'm not talking about the number itself, I'm talking about the inside-outside total. So in this case, I have a 15 and a 24 to equal 39. Right? And those things you just have to work at. Because sometimes you get it on the first shot and you think, man, that's cool, this was easy. Sometimes it takes you 2 or 3 times to figure out which ones work. But if you don't test it, you don't check it, then you're just guessing. Okay? Now, remember those? Okay, that's all part of this chapter. All right, factors of 30, all right, going in the first positions, factors of 40 or 50 go in the last. And I need to add them up, and they end up having to add up to be 95. Now here's something that I said. If this is a 95, then that means that I have to have either 2 negatives or 2 odd numbers multiplied together, or an even and an odd number multiplied together. Because if I have all even numbers together, I can't get an odd sum. Okay? So that means that when I'm looking at this, I can't have the 2 and this 2, I can't have them on inside and outside. So if you'll notice, the 2 and the 10 come together, so that this gives me an even number, and then the 2 odd numbers give me an odd number, so when I add them, I end up with an odd number. And that's a little bit weird, you wouldn't know that, but the reason I'm telling you that is that will help you to eliminate some of the combinations you have to do. If you have an odd number here, that means you have to get one of these multiplications, inside-outside multiplications, has to be odd if this is an odd number. Okay, otherwise, why did you learn that stuff when you were back in, what, 2nd, 3rd, and 4th grade? Right, there was a reason that even odd numbers were taught, and this is one of them, so that when you're factoring, you can identify where those numbers have to go. Okay? All right, now, all right, let's see if I can get to this other page here. All right. Now, factoring is important for problems like this. Okay, so let's look at this. And if you have either in your notes or something like that, okay, in order to be able to divide this, these are 2 fractions. Okay, did you learn a fraction rule for division? Something like copy, change, flip, or right, copy, change, change. So that means that after I'm going to do something with this, and then I'm going to change this to multiply, and I'm going to flip that fraction. Right? That's one of the things that you have to be able to do. Now, the question is, does this factor, does x squared minus 25 factor? The answer is yes. Into what? Oh, wait, give me a C word. Into what?
Conjugates.
Conjugates, right? So this is going to be what?
X plus
5.
X plus 5, X minus 5. Okay, I've factored that. Now what about this? Now again, here we have a plus. Signs are the same, and they add up to 5. What are the factors of 6 times 1? What are the factors of 6 that add up to 5?
2 and 30.
So this is x2, and this is x3. That adds up to 5. They both have to be negative. Okay? Now, copy, change, flip. Now I'm going to turn this around to x plus 5. Okay? Now, what happens next? All right, do you see anything that would cancel?
Yeah, X plus 5.
X plus 5's cancel.
And the X minus 2.
And X minus 2's cancel. And so the correct answer is X minus 5 over X minus 3. Okay, now how many different skills? All right, one skill for the difference of squares, one skill for the trinomial, and one skill for changing, dividing into multiplying. That's 3 skills. And then simplification or canceling is 4 skills. 4 different skills to be able to do the one problem. All right. And that was relatively simple as far as, because this one went so fast.
Yeah.
Right? Okay. Now, all right. What's the next one say over here? Subtract. Okay, so in order to subtract fractions, what has to be true?
Denominators are the same.
Denominators have to be the same. So it looks like that I need a denominator that's this. Would you agree?
Yes. Yes.
Okay, if that's true, then in order to keep this fraction the same, I have to multiply this by the same value. In order to keep this fraction the same, I have to multiply the numerator. And so now I have common denominator, but I have 7 times this first binomial, which is 7x minus 35. Now, negative 3 times x is negative 3x, and negative 3 times 6 is negative 18. All right, what happens when I combine those? What do you see? X's. Tell me what you see. Faux, right?
Yeah.
Faux X's?
Yeah.
Right? 7 minus 3 is x is 4x. And then negative 35, if it's 20, that would be 55, so it's 53, because that was only 18. Now, what happens to the denominator? The denominator has to be multiplied. So what happens when you FOIL those? All right? What's x times x?
X squared.
X squared. And then the end is negative 5 times 6. Negative 30. Inside is negative 5. Outside is positive 6. Add them together and get 1. So the numerator becomes 4x minus 53. And the denominator is x squared plus x minus 30. All right, and that, if you had a multiple choice, test, do you think you would have chose that answer for that subtraction problem?
Nope.
Probably not, right? And so the only people that are going to get this right are the people that begin to understand how to be able to use the common denominator when it's a binomial, not just a regular number. Okay? All right, question? Okay, now, let's look at, because you've opened to 406 and we haven't got there yet, have we? Okay? All right, so let's look at review problem 1. Okay? Now, okay, if you'll notice, review problem 1 has a trinomial in the denominator. Isn't that nice math words? Okay, so therefore, what do you probably have to do with that trinomial? You're going to factor it. Okay, so will it factor? That's the one we just used, wasn't it? Okay, factors of 6 that add up to negative 5.
2 and 3.
-2, -3, okay? And then what's going to happen with the numerator and the denominator? The -3's will cancel, won't they? And so the answer is going to be 1 over x minus 2. All right, now, here's the other thing that you have to remember. When we started, we had x minus 3 and x minus 2. So we have two values that the domain cannot equal because you'd have division by 0. So the domain says all values of x except 2 and 3. Now, when you get into graphing these equations, if you cancel, that ends up being a whole, right? If there's only a number in the denominator, that ends up being an asymptote that the graph will not cross. Okay, remember doing all that? Yeah. Okay. All right. So those are the basic questions for R1. Now, to draw the graph, okay, here's the thing. The graph of a value of some constant over a binomial is a hyperbola. What does the hyperbola look like from your conic sections? All right, if you remember, in the hyperbola, we took and did, and we went like this or like this. Okay, for 1 over x, right, it starts here, it looks like this. It's in the first and the third. If this were a negative, it would be in the second and fourth. Okay, but it looks similar to this, right, because in this case the asymptote is x equals 0, and here my asymptotes have to do with the values that produce that box. Okay, so, all right, so when you graph it, that's what it's going to look like. It's going to look like this. Now, I said this to somebody last week. This used to be taught in 8th grade. And they couldn't get it, a lot of them, because it really is too complex. But the same thing, what's a square root graph look like? Square root graph starts here and goes like that. Right? Because if x is 1, y is 1. If x is 4, y is 2. And if x is 9, y is 3. And so it's off the page in a hurry. Okay? But the 8th graders used to have to memorize all of the shapes of those graphs, so that when they took in 9th grade, when they took Algebra 1, they already had the base of understanding for where we are right now. Okay, now, so look at R3. Okay, now, what do you notice about R3A? Look at R3A. What do you notice? I want a vocabulary word. They're conjugates. So what's going to happen to the middle term? It's going to disappear. It's going to zero out, right? And so the first term when you square it is what? 9x squared. And what is the last term when you square it?
49y squared.
49y squared. What will be the sign in the middle?
Negative.
Negative. Okay, very good. That's how that works. Now, R3b is asking you to do the long multiplication problem. You multiply the trinomial times x, and then when you multiply it by 3, you slide everything over one place, and they're all lined up, and you'll have 4 terms when you're done. All right, factor completely. Look at D in R3. All right, what common number do they have?
3.
They have a 3. Good. What common variable do they have? Only an x. When you take 3x out of the first, you're left with 2a, and then a plus, and when you take 3x out of the second one, you're left with 5b. So it'll be 3x parentheses, 2a plus 5b, and the rest of them work similarly. Okay, now, look at C, or E. Look at E. All right? What is the relationship in E? 3E is a, look for 3-word answer. DOS. Difference of squares.
I heard BOS. I was like, wait.
All right, that's difference of squares. Can you see it? You see it's difference of squares? So what will be the answer to what? Vocabulary word. Starts with C.
Two conjugates.
2 conjugates. All right, and then factor completely. Do you notice that there's no number in common? So we can't pull a number out because in F, because we have a 2, a 21, and a 36. So therefore, I want to factor this. There's only one way to factor 2x squared. What is it? With whole numbers, what's the only way to factor 2x squared?
One of them's going to be 2.
One of them's 2x, the other one's 1x. Right? So you already know that if this is factorable with whole numbers, you can have parentheses 2x and then parentheses with a 1x or just an x, and then all you've got to do is figure out inside outside has to total 21. Okay, now, what will the signs be, the same or different? For problem 3F, will the signs be the same or different?
They would be different.
Why?
Yes, because it would be...
Because in order to get a negative 36, you have to have one positive and one negative. So the signs will be different. Okay? All right, now you're supposed to be doing down through 5, I think, right?
Of T though, right?
Yeah, well, yeah, this is a review, which you were supposed to have already done.
Yeah.
So you need to do the review, and then if you turn to the test on 410, I want you to do, I want to see you do 1 to 6. Let me see if I want to go back to the directions. All right, this says 1 to 4. I want you to do 1 to 6. Okay, do 1 to 6. Because problem 5 and problem 6 are the Algebra II factoring problems. So I want you, now here's the other thing, is that I want to see your work on this particular test. Well, let me stop. Okay, problem 4 and 5 and 6, you're going to have to show me work. Problems T1 and T2 are going to be problems that that are just straight answers. Okay. All right. So that's problem. Okay. So so which problems are you doing?
T1 to 6.
T1 through T6. Okay. Now, if you've already done the review, if you'll notice the test problems don't cover all of the work that's in the review. So what am I saying? So we've covered all the stuff that's in the test problem with one exception. The only problem we haven't covered is T2. Okay, that should be in your notes.
Is the test routine still a test paper?
That, no, yes, the one paper that I pulled, that you were not, which was I think test 36 or 39, whatever it was. The one that had the cumulative, it was the first page of the cumulative review. All right, we said don't do that one. These two tests are going to be done anyway. All right, so you're going to do the chapter test and turn it in. All right, I'm going to grade it and give you a grade. Yes.
Are we supposed to turn in the review
I had wanted you to, that was what that's the reason I assigned it before we went on break, is I wanted you to do the review and turn it in, and then we were going to talk about the things that you didn't understand. Right? But because of the confusion, I didn't have enough of a class that actually did that assignment, so that's the reason we're doing it this way. Okay, so the question that if I can rephrase it, do you have to do the review problems now for Chapter 7? And my answer is no, unless you can't figure out how to do those problems, in which case you're going to have to go back to your notes.
Yeah.
Now, I would like you to stop putting this thing in Google and coming up with an answer. Because I want you to be able to do the work and demonstrate. So if I see just an answer, in fact, there were several problems that I was grading in the group that I didn't give full credit for an answer because the work that was done, the jump from where they stopped to the answer made no sense.
Yeah.
Right? And so somebody got stuck, or it was more than one person, but a person got stuck and then looked up the answer and plugged the answer in. Right, but did not get full credit because you weren't demonstrating you could do it. Okay, so let's try to. I would rather have you get it wrong because you can't do it and try it. Because what happens when you make a mistake?
Give up.
No, well, you give up. But I'm saying when you make a mistake and it's counted wrong, you get half the points back anyway.
Right.
You know, you need to be more honest with yourself. Right. When I was teaching in regular school, in middle school, if a person couldn't live without an A or a B, my goodness, there's ways to get an A or a B. But what I wanted to see was whether or not they could do the work, because they were getting ready for where you are now. They're getting ready for high school. So if they didn't know how to multiply and didn't know what 6 times 7 was. When they got to high school, they were going to have problems. All right? Okay, now, that's 7. So now we got to go to 9. Okay? So turn, if you will, to the review on page 507. Almost. Okay, now, that is one of my favorite topics, if I can find it here. Right, this is conic sections. All right, so this is important. All right, now, what you're supposed to be able to do is know the basic structure of the conic sections. Okay? So, when you see a circle, you are supposed to already know what does the equation basically look like. All right, so what does the equation of a circle basically look like? It has a plus with an x squared and a plus with a y squared.
Yep.
Okay? Now, sometimes they put the same value here, right? But the coefficients have to be the same, and you have to have squares on both, and they both have to be positive.
Right.
And now, one of the things that we're doing with this is that how do you complete the square? You take what?
Take half.
Half the x term or half the y term and make the binomial square, but then you have to add the extra number. Okay, so circles are going to have x squared, y squared. Okay, now, if it was x squared, y squared, then the center of the circle is at 0, 0.
Yep.
If it was x minus 3, you're going to use the opposite of the number that you see. That hasn't changed. Okay? Now, next, ellipse. Ellipse. What's an ellipse look like? Isn't an ellipse a weird circle?
Yeah.
All right, so therefore, it has to have an x squared and a positive y squared, but one of these is going to be different than the other as far as the leading coefficient is concerned. They'll both be positive, but they'll be different. All right? Now, this causes some problems when you go to complete the square. So if I had 4x squared minus 64x, when I factor out the 4, this is going to give me x squared minus 16. Half of that is x minus 8 squared. Okay? So I take the 4 out, get 16. Half the 4 is 8. Now, when I go to find the extra number, I say 8 squared is 64. 64 times 4, I don't know what that is, 116, 216. And because this is positive 216, I have to add a negative 216 to make it equal.
Right.
Okay? So, completing the squares on the ellipse and the hyperbola are the hardest math that we've got by far.
Right.
By far the hardest math. And that's if the teacher is nice and gives you a number that's even. If the number's odd, it's even worse.
Yeah.
Okay? All right, so now we've got circle, which has 2 squares, both positive. And then we have the ellipse, which is 2 squares, both positive, but the leading coefficients are different.
Right.
So now we go to parabola.
Only 1 square.
A parabola has 1 square and 1 not. Okay? So, if I have y equals x squared, this is the parabola we've been working with. Which way does this open? It opens up with a y-axis, which is a single number. Okay? So, if it's negative, it'll open down. But what happens if the x and y switch? And this is the reason why I tell you. You know this. So if I switch it and say y squared equals x, right? Now it's going to be along the x-axis, and so I'm going to have a line of symmetry like that. Okay? That's this one. Now, because you know this one, and you know that the axis is along the y, it's looking like that, then you should be able to figure this one out without having to memorize what it looks like. I don't memorize that one, I just figure it out.
Right.
Okay, makes sense? Now, what would happen if this was a negative here? Then instead of opening positive, it's flipped around and opening negative. Make sense? Okay, all right, good. Now, so then we come to the hyperbola. Right? The hyperbola and the ellipse are related. Remember when we were doing all the graphing? Is that we use the same rectangular box? Right? And so therefore, I have an a x squared and a by squared, but one of them is positive, one of them is negative. Now, the leading one is the axis. So that means this is the axis along the x. If I had y squared first and x second, then I would be using the top and bottom. Okay. Now, most of what you're going to do for conic sections is based in that skill that we just went over, because you have to figure out what is the type of conic section based on the graph, and then you go about graphing it. Okay, so let's look at on page 507. Let's look at the review. Okay, now what do you notice about little Roman numeral I? 1. Okay, Roman numeral 1. What is the type of conic section? It's a circle, right? Everybody, why? Because both positive, both square. Okay, now here's the thing. The center of this circle is at 0, 0. Right, now think about that. The center of the circle is at 0, 0. What is the radius of the circle? 6, okay? So, what happens if I don't go 6, but I go less than 6? Where am I going to be? Inside the circle. right? If I go less than 6, I won't make it to the edge of the circle. What happens if I go more than 6? I'll be outside the circle. That's what takes care of the greater than or less than sign. See that? From the major point, right? Even with the ellipse, the major point is in the center of the ellipse, right? So if you're greater than the ellipse, you're going to be outside of the ellipse. If you're less than the ellipse, it means you never made it to the line, and so you're inside. Okay, that's all that issue. All right, not hard, but if you look at it based on what I've just tried to explain, the greater than or less than takes care of itself. Okay? All right, so look at VII, which is 7. Look at 7. Okay, what do you notice? It's not a circle. It would have been a circle, but it's not. It's a what? It's an ellipse, because they're both positive, but one has a lead of 1, the other has a lead of 4. Okay? Now, go to XI, which is 11. Okay, we have an x squared and a negative y squared. So what is it? Hyperbola. Okay? Now, how do you complete the square with the x? You take half of 10, so it's going to be x plus 5 squared. And what's the extra number? 5 times 5? 25. Because I have a 25 on the left, I'm going to put a 25 on the right. Okay, then what about the other one? The other one, the first thing you have to do is take out the negative 9. When you take out the negative 9, that's going to leave you negative 6. Because negative 9 times negative 6 is positive 54. So what's half of negative 6? Negative 3. Okay, so now I have a negative 3. X minus 3 squared. So what's 3 squared? 9. 9 times negative 9 is negative 81. Because I have a negative 81 on the left, I'm going to put a negative 81 on the right. Okay, those are the most difficult to do, but the rest of them are relatively straightforward. Okay? Now, R2 says write the definition. Okay? We didn't go over that. A circle is equidistant from the center. An ellipse is equidistant from the focus points. We didn't even cover focus points because he doesn't. All right.
It had it on the test.
Is it?
I never done it before, because I remember.
Okay. Again, it's not, the focus points are not, he doesn't cut, well, never mind, it doesn't matter. The focus points aren't covered. Hyperbola, it's the difference from the two focus points, and the parabola is between the focus point and the directrix. I don't think you need any of those for the test. You know what I'm saying? You don't need any of those for that test. Okay. Now, systems of equations with the different types of conic sections. All right, that's not going to be tested either. Because we're stopping at 5. Okay? All right, so now, if we go down to the test. Where do I go? Where am I? Okay, now you are going to do 1 through 5. So this is 1 through 5, but in this one you're doing 1 through 6. How much time do we have?
15 minutes.
15 minutes, okay? All right.
Mr. B,
Yes.
can I run to the bathroom real quick?
You can walk.
Yeah, okay.
Yeah, 1 through 6 on 7 and 1 through 5 on. Okay, so let's go over some of this practice while we're. All right, what do you see in this first one, Ruben? What do you see here?
I see a 2 squared.
All right, that's a 2 squared. But in order to be able to do the conic section, we've got to look at the other side. What do you notice? Do you have squares for both?
Yeah.
So then it's not a parabola, is it?
No.
Okay, so all right, now what about the coefficients in front? They're both 1. So if the coefficients are the same and they're both squared and both positive, then what is the conic section? What letter is that?
It's a C.
C. So it's a
Circle.
circle. It's a circle. Okay. Now, what's the radius of the circle? It's 2. This is normally going to be a 4. All right. So you have to take the square root of it, because this is r squared. So the r is 2, and it was squared. And so because the center is at -3, 5, and has a radius of 2, then I'm going to draw my circle the best I can like that.
What if they were going to the 30?
What?
What if they were to the 30?
Then it wouldn't be a conic section. Okay. Remember what we started with, that to identify a circle, you had x squared and y squared. If you multiply this out, you're going to have x squared and y squared.
About the 2.
This 2 is a combination of 9, 25, and 4. So if I had this before, because there's a 9 here, I would have a 9 over here. Because there's a 25 here, I have a 25 over here. And then, so when this is negative, the result is going to be 4. But that's the value that you're looking at when it's put in its final form. Now, what about number 2 then, Ruben? What do you notice in number 2? Are they both squared?
Yeah.
Okay, so are the coefficients both positive? Coefficients in here.
Oh, yeah.
Okay, all right. And then, so if they're both squared, both positive, then it's again a circle. All right, what's the radius of the circle? Half, or square root of it. The radius of the circle is 4. Okay, where's the center? Let's see. Sydney, where's the center?
4.
For number 2. For number 2.
Oh,
Opposite. It's at 4, -3. 4, -3, and the radius is 4. Then draw the circle. Okay. All right, now. Okay, so now, what is it? Is this a circle? Is this a circle?
which one?
Number 4.
No.
Why? Because this coefficient is 1 over 25, and this coefficient is 1 over 9. All right? Technically, I would have had a 9 here, and a 25 here, and I think I would have had a 226 here.
Oh.
Right? So, no, I'm sorry. No, this would have been a 225. So when you divide everything by 225, the 9 cancels, you have 25. The 25 cancels, you have 9. And 225 or 225 gives you a 1. All right, but in this case, all right, what kind of conic section is that?
That's an ellipse.
It's an ellipse, okay? So, the center of the ellipse is at, Ruben, this is important. Where's the center of this ellipse? Opposite.
4, 6.
4, -6, opposite, opposite. So at 4, -6 is here. Okay, now, the x direction, I'm going to have an axis of how long? 5 in each direction. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. My y is going to go how far?
3.
3 in each direction. 1, 2, 3, and 1, 2, 3. All right, and that makes this box, because this is positive. All right, because this is positive, I'll put the ellipse inside the box. If this were negative, I'd have a hyperbola, and I would take my diagonals this way and this way. And then along the x-axis, I would do this. And if you remember those now? Okay. So the hyperbola and the ellipse use the same information, only one puts an ellipse inside the box, the other puts a hyperbola on the diagonals on the outside. Okay? All right, so now the hardest problem is number 6.
Ooh, let's see. It's not a parabola. It's not a parabola.
All right. If you'll notice, this is positive 9 and positive 4, so it's not a hyperbola. Because these are different, it's an ellipse. Okay. All right, that's good. And it is 16, we got to 20, right?
Yes.
Right? No,
25.
25, that's right. We started 16.
Yeah.
15. Okay? All right, so, all right, let's look at this one. Okay, what do you notice?
Let's see, yes, hyperbola.
Hyperbola, okay? So, where's the center going to be?
5, 6.
5, 6, okay. On your paper, if you will, draw a coordinate plane, and then at 5, 6, put a dot. It doesn't have to, well, it doesn't have to be perfect.
This is my sketches.
Now, all right, now we have to get an axis. The axis along the x is how far?
4.
4. Because this is at 5, I'm not going to cross it, right? I'm going to come down to here and out to here. Okay. Now, what about the y-axis?
3.
3 in each direction. Up 3 and down 3. And now, make the rectangle with dashed lines. Make the rectangle. Now, because the x is first, we're going to use the x direction. All right, now, how do you draw the diagonals? I don't draw through the center of the box anymore. Right? I start down the center of the box and then take that way. Start down the center just so that I'm lining it up. Okay. Now, if you use this dot and go up to those diagonals like an asymptote, you're done. You don't have, now, see, had this been plus, you would have done the ellipse on the inside. But because this is minus, you're doing the hyperbola on the outside. But the first, and Sydney, the reason I taught it that way is that whether this is plus or minus, you got to get that box. Right? And so learning how to get the box helps you for both of them. But yeah, you don't have to put the ellipse inside because this is a minus. All right? Okay, good question. All right? Okay. Now. Okay, so those are pretty straightforward because all the work in the graph was done for you. Oh, here it is, okay. All right, so now we got this.
Oh my, 13 or 14?
We'll do 13 first.
13, so it is a...
Now, do you notice this is x squared with a 9, this is y squared with a negative 25. So what kind of graph? Hyperbola, because one's positive, one's negative. All right, now, so therefore I have to take 9 here. What happens when I factor a 9 out of this?
It's 6.
It's 6. Half of 6?
3.
So that makes this x minus 3 squared. And you should be able to do that in your head. All right, if it's a fair problem, all right, those numbers should factor well.
Yeah.
Okay? Now, the next one's trickier. All right? If I take negative 25 out of this, what's left? A negative 2, right?
Yeah.
Because negative 25 times negative 2 is 50. What's half of negative 2? Negative 1. So this will become y minus 1 squared. Okay? Equals. Now, I have a 225, but what extra number do I add with this binomial?
9.
9 times 9.
81.
Because there's an 81 there, have an 81 there. Okay? Now, this is 1. 1 squared is 1. 1 times negative 25 is negative 25. And then you'd add all those together and divide. Okay? Now, I didn't correct this problem because that's not going to work out perfect. Okay? But what we're going to do is we're going to pretend it does. And when we do that, this is going to be 25. This is going to be 9. This will be 1. Now, where's the center?
3.
3, 1. Center's right there. Okay?
That's 2.
Oh, thank you. Okay? Now, the x direction? 5. 3, 4, 5. We go here. And then 3, 4, 5 goes here. Y direction?
Tree.
Up tree. And down, 1, 2, tree. And so there's my box. Okay, and then diagonals go like this. The rest of it's easy. Right? Okay, makes sense? Okay, now, when you look at this next one, what do you see? What do you see for this one?
It is a circle.
All right, 3 and 3, so it's going to be a circle. Okay? Now, here's the question. When I take a 3 out of here, what's left?
X and, 7? 8.
8. Half of 8? So this is x plus 4 squared. All right, when I take a 3 out of this, I get 12. So this is plus 3 times half of 12.
6.
Y plus 6. And then I'm going to take this minus 81. Now, 4 squared? 16. 16 times 3 is 48. And then 6 squared? 36. And 3 times 36, I think, is 48.
Wait, 3 times 36?
This one is
36 times 3?
108.
108. Sorry. What did I do? Not sure. 3. No. Oh, it's 36. I was a little behind by 6. Okay, 108. All right, when you add all those up, you're supposed to get a perfect square. What is 108? 20. 25?
That's an 8.
7?
75.
75? Okay, yeah. All right, so this is 75. Divide everything by 3. And that cancels, and this becomes a 25. All right, now, where's the center of this circle? Ruben, where's the center of this circle?
-4,
Very good, okay. Area, what's the radius?
5.
5. Okay. All right, so you have 2 tests. All right, you have 2 tests to do. All right, and how many have the handout? All right, I'm going to turn this off. I'll collect your handout and then we'll hold it back up.